Hello all. Now we are going to discuss about storage classes in C. This is our course route map. We will be having a small introduction and different types of storage class with explanation to each of them. So in addition to having a data type like int, character, float and double, every variable in C program also belongs to a storage class. Storage class helps us in providing info related to where the variable has been stored, variable's default value, scope, and lifetime. In C, we are having four types of storage classes. They are auto, static, register, and external. Let's have a look at each type of storage class in detail. First one, auto storage class. Automatic variables are always declared within a function and are local to the function in which they have defined. That is, their scope is conformed to that function. Because of the property, automatic variables are also referred as local or internal variables. Automatic variables defined in a different functions thus be independent of one another, even they have the same name. Any variable declared within a function is interpreted as a automatic variable unless a different storage class specification is included within the declaration. So the storage classes will be giving the main four details to us. The first thing, where the variable has been stored, next default value, and then scope, and then lifetime of the particular variable. For auto variables, the memory will be in stack of the main memory. Default value of auto variables is garbage value. So if we are not going to initialize with any value, the default value of a local variable or a auto variables is garbage value. Scope would be always to the local to the block in which the variable is defined. Okay, so auto variables remains alive till the control inside the block. If that particular control is coming out of that block which the variable has been defined, after that the variable will not be accessible. So if you are trying to access it, we will be getting errors. So let's have some examples about this auto. So for this I'll be using a online compiler, compileonline.com. So this is GCC version 4.8.1. Let's have this example. See, I'm declaring three variables: integer, a character, and a float. I'm trying to print those default values. So we are getting the output here. So these are actually the garbage values. Okay, so for integer we are getting some random number, for character we are getting blank, and the float we are getting some 0.00. Yes, those are automatic or local variables and they have not been initialized with a specific value. Those values are will be garbage or null. If we are going to print any pointers, those values will be null. And the next example, I have been collected some case studies for these storage classes. I'll be explaining them in detail. The next one is visibility of auto variables is within the block where it has been declared. So this is our actually one of the characteristics of storage class. So for auto variables, it will be always within the block. Let's have a look at this. So here I have declared int variable equal to 5. Inside the block, I'm again define the variable as 10. I'm trying to print inside the block and outside the blocks. Let's have the output 10 and 5. So here the explanation. The first one, int variable equal to 5, and again after that the same variable name with the same name variable has been updated with 10. We are trying to print the variable, we got 10. After that we are trying to again print the same variable, but we got 5 because that particular 10 has been updated within the block. So if you are coming out of the block, that 10 has been collapsed, we will not be get the 10 anymore. So outside the block we are getting, we have been initialized with 5, so we are getting 5. So for the same scenario we will be having one more example here. See here I have been declared a variable int a with a value 20. I have been trying to print the same variable. After main I am trying to print a. So let's have a look what the output will be. See at the line number 7 we are getting error. See, because int a, this has been declared and defined inside the block of main. After that main has been ended at the 6th line. In 7th line I am trying to access the variable a. So it has been not declared or defined outside the block. So we are trying to access a variable which is actually not in the scope of that particular block. So we are getting error for it. For the same scenario, the next one. See, I have been declared a variable int I. Here I have initialized with 0 and then I am trying to increment them. This is a for loop, and I have declared and defined a variable a with 15 inside the for loop. I am trying to print it and I am trying to increment the same variable a. So what would be the output? Have a look. 15 and 15 and 15. Let's give a space here. We'll be getting a clear view. 15 and 15 and 15. See, observe this. I'm trying to increment the variable a, but I'm not able to get incremented value because in for loop I have been declaring and define the variable. So after this, actually, see, this for loop will be executed 3 times. Once it has been executed first time, it will come out of the loop and it will start again. So then that particular variable a will be collapsed, and then in the second time it will re-initialized with 15. So always it would be 15. Okay. Next, static storage class. So next one is static storage class. Static is a different kind of storage class. So unlike auto variables, it is also local to the block which is been defined, but whenever we are going to initialize or define outside the block, like in global, it will be having a restricted to the particular file which it been declared. So one more, the main property of static variables are local to the particular function, but their values are retained across the function class. Okay, whenever we are having a static variable inside a function, if that function is getting number of calls, so based on the calls, if that particular static variable is going to update, it will be stored the last updated value. So this is the main, actually the main concept of static storage class. And So the main one more point I can say, like the a static variable is initialized only once when a program is compiled. So it is never initialized again. So like external variables, if no explicit initialization statement is given, a static variable is automatically initialized to 0. So the next step is the main four properties of static storage classes are: static variables are stored in data segment. The default value of static variables is 0. So if you are not going to give any particular value at the time of initialization, the default value will be 0. So scope and lifetime will be a different compared to other storage classes. So we'll be having two different kind of things here. The scope for local static variables is local to the block, and global static variables is within a file. Okay, so local static variables value retains between the function calls, and for global static variables it will be alive till the program execution does not come to an end. So this is what the static storage class. So for static we can say the examples. I have prepared some list for static also. Let's have a look at static also. So default values, let's have a look at default value. I have declared four variables with static. I'm going to print those values. I have not given any specific value to those variables. See here. First one, for character, for integer, float, and for pointer. So for pointer we are going to get null. So these are the default values. So if we are going to print as, see, just remember, so it is a static integer, so the default value is 0. For auto variables the same default value would be some garbage value. Have a note. And one more case scenario here. So these are actually we need to note down for each storage classes. So for static variables we cannot assign again the values to the static variables in globally. Have a look. See here, for I have been declared and defined with 10, and then I'm trying to initialize, I'm trying to assign with 25. So there the compiler has been given the error like redefinition, because global, when we are going to initialize in global, static variables will be initialized only once. So you cannot assign the value again and again. One more example. Have a look. See here, I have initialized with 10, and then in main function I have been assigned with 25. So this is what the difference between previous program and this program. In previous program I was trying to initialize with 10 and then again assign with 25 in globally. So globally we cannot assign the value again and again, so it would be like a redefinition. But you can do in the local, you can define a value statically in global and then you can update the same value in local. So we'll be getting updated value. So this is the main. concept of static actually. So this program, if we got the info from this program properly, we'll be getting a proper info about static variables. I have declared and defined static integer I equal to 10, and in main program I have been defined with 5 again. So in for loop I am using the same variable I. Inside them I am using a static variable a with 10. So after that I'm trying to print value a with incrementing it at each iteration of the for loop. So let's see what is the value. So it is 10, 11, 12, 13, 14. You might have noticed that in auto variables, whenever the for loop has been executed at the first time or the second time, so it is going to start and then it will re-execute. So the value whatever you are going to define, and the same value will be printed. But in static, only one time it is going to initialize and then it is going to update with the latest value. So that's what I'm doing here. So I have been initialized with 10, then I am trying to increment the value a. So after execution of first iteration, so the value will be incremented with 1. For the second one more, the value will be 10, and then 11, and then 12, 13, 14. So this is what the main property of static variables. It will be having the last updated value with it. Okay. And next case study is, if we declared a static variable locally, then its visibility will be within a block where it has been declared. See, have a look. See, I have declared a static variable a equal to 5 in main block. So outside the block I'm trying to access it. So it will not be possible as it is not a global value. So you cannot access outside the block if it is declared locally. Next. Okay. So next one is register storage class. So this is a special storage class, I can say. So a register declaration will be like it is giving a notation or a advice to the compiler that the variable will be uh, used often. Like it is in the program it will be called so many times. So it would be better if we can store them in CPU registers so that the program can access them fastly. So this is the main funda behind the register storage classes. So if you are going to declare a variable with register, the compiler will be try to store that particular value in CPU registers. So here the compiler will be having a like it can ignore it out based on the data type. It can store or it may not store. And one more thing is CPU registers are very limited in number. So if it is the particular number has been occupied, so it will not be considered as a register storage class. So then it will automatically converted into auto variables. CPU registers would be 16-bit or 32-bit. So you cannot store all the data types in CPU registers. So for example, W is 64-bit. Then it will not be stored in CPU registers. So here I want to put one more point, like register variables are not addressable. Only memory is addressable. So this I will be showing an example. So the main four characteristics of this register storage class are: the values will be stored in CPU registers, default values will be garbage value, scope will be local to the block. Registers variables remain still until the control remains inside the block. So it is almost the same to the auto variables. The thing is like, if it is having a number of CPU registers available, that particular variables will be tried to store in that CPU registers. So if there are no any CPU registers, it will be stored in stack of the memory. It will be converted into automatically like a auto variables. So other three properties are same to auto variables. So let's have some examples here. So these examples actually made for like the last point I have been told you, like register variables are not addressable, only memory is addressable. So let's have a look at this. See here, I have declared a register variable A initialized with 10 and a integer pointer. I'm trying to access those address, the particular variable's address in P. So I'm trying to print it. So the main concept is the address of register variables. So we cannot address it, so we cannot access it. So this particular thing we cannot do. So we cannot dereference it. So register variables cannot be dereferenced. One more thing for the same concept I can say. So here I have two register variables. I'm trying to get some data to those variables and I'm trying to print it. So here I am giving the data 10, 20. See in the line number 4. So because here we are going to access those variables with the reference address. So while converting those variables, those data into the variables, we are trying to actual the behind formula would be like dereferencing the variables. So dereferencing the variables is not possible for storage register storage classes. So it will not be compiled. So we will be getting error for it. So this is what about storage register storage classes. So main thing will be like the particular variable, if we want to access number of times, more number of times I can say in a program, so it is advised to declare that particular variable as register, but it is depend upon the compiler. It may take those advices or it may ignore it based on the availability of registers. Next, extern or global storage class. So basically, if you are going to declare a variable as extern, so the particular compiler will not create any variable. So but it will be having a info like, okay, with this name some variable is going to define in somewhere else. It may be in the same file, it may be in some other file. So this is what the main advantages of external variables are. We can have external linkage to the particular variable. So what is that external linkage means? We can have the linkage between multiple files. You can declare an external variable in one file and you can define those particular variable in different files in globally, and you can update them. Those values will be updated. So these external variables will not consume any memory. So here the main 4 characteristics of storage classes would be like, so basically it does not consume any memory, so it will not be stored anywhere. The default value, the value also you cannot print. If you are going to declare a variable as extern, you cannot print the value unless until it has been defined somewhere else. Okay, and then lifetime and scope would be depend upon the linkage what you have been provided. If it's a external linkage, so until that program has been executed. If it is an internal linkage, until that file the program has been executed in that file. Okay, so let's have the examples. You can have some more examples. So extern, I have declared a extern variable here. I'm trying to print inside the main. So by default, if you are not having this extern keyword, that particular variable I would be globally declared as a global variable. So you can access anywhere in the same file. So let's see what will happen if it is extern. See, that means we are getting error here. That means extern int I will be a info given to the compiler like a integer variable with the name I will be defined somewhere else in the same program or in some other program. So we need to be have a separate. So the particular variable has not been created. If it is defined in globally, then the variable I would be created. As of now, it is not created. If you want to create, you need to create I here. So then the error will not come. Okay. One more case study. You cannot initialize external variables. See, extern means you have to declare it. That's it. Definition should be done separately. And the below line or below the block or at the end of the file, maybe in the some other file. So that's how it is. And the last one, so initialization, how we can do the initialization for the external variables. I have declared a integer variable as extern. I have defined here. So the compiler will be having a info like, okay, a variable with a integer variable with I is going to define somewhere else. So we can link it to this particular extern int I. So whenever I am trying to print it, the particular compiler will be looking at the actual reference to the definition of that particular variable. So in the same file I have been defined it as 20, so that compiler has been looked into the info. It is try to print the value 20, it is printed. Next. So this is what the storage classes basically in C in briefly. So as a summary, I can give this table as if we want to quick reference to the storage classes, we can go with this table. So the table will be like, in this line I have been given the storage classes, different types of storage classes. Here I have been given the properties of those storage classes, like where it has been stored, the value, default value, scope and lifetime. So this is what we have been discussed in the same previous slides. So if we go through this particular table as a quick reference, we can get the actual data from the same table. So thank you for watching.